Greetings, students. Today we're going to discuss Prospects Test 1-5. Let's begin. Question 1. We're looking at these two angles. They are adjacent, and they make a straight line, so these are supplementary pair. So I take x plus, and 5 and 140 is 145, is equal to 180, and I subtract 145 from 180 to get the value of x, which is 35 in this case. Question 2. These two angles are adjacent, and they are complementary because they make a box or corner. So I'll take b plus 27, and I'll set that equal to 90. 27 from 90 is 63 degrees in value. Question 3. These two angles are across from each other. They make an x, so they are equivalent. They are vertical. So I'll take 3 from 43 to get 40. I'll divide 40 by 4 to get 10. Question 4. We have two adjacent segments, making a longer segment underneath it. So we'll add those two together, x plus 1 plus 12. That will make x plus 13. And that will be equal in value to 5x minus 3. I'll take x from 5x to yield 4x. I'll add 3 to 13 to yield 16. And I'll divide 4 into 16 to get 4. All right, so we have segment addition postulate, vertical angles, complementary angles, supplementary angles so far. 5 points each. Question 5. We are looking here for this on this question. We are looking for the angle EFG. Find EFG. So EFG is the entire angle. So when I'm looking at this diagram, and if I'm looking for the entire angle, I'm going to add the two given angles. Again, you're either going to add or you're going to subtract on this question, depending on which angle you're looking for. Looking for the entire angle? Well, we're going to add. Looking for a portion of the angle? Well, then we're going to subtract. So 5 and 8 is 13. 1, 2, 4, 143 is my value of my angle EFG. Question 6, looking for angle, let's looking for the value of x. So again, I'm looking for which one is the entire angle, because the other two add up to make it. So this is angle UTS, or STU. So that angle there, 7x plus 7, is the entire angle. The other two angles add together to make it. So 7x plus 7, these other two angles, we're going to add them together to make that 7x plus 7. So this is 5x plus 10 plus the 21. Those two, they add together. So it's 5x plus 10 plus 21, so 5x plus 31. Because the other two add together to make the entire angle. 5x from 7x is 2x. 7 from 31 is 24. And 2 into 24 is 12. Anyhow, so this is our angle addition postulate. This is our angle addition postulate as well. Keep in mind that we could make these be subtraction problems if we're looking for one of the angles inside, one of the smaller angles. We would end up subtracting. Question 7, distance. Has not changed since the original question we had 4 tests ago. So the x's here, from -5 to 3, those x's are 8 apart. -5 minus 3, that's 8 apart. Now I put -8, it doesn't matter here. Because from 3 to -5 it does decrease by 8, but it doesn't matter here because we're going to square it and add it anyways. And then the y's are 3 apart. And I did put -3 here, but that doesn't matter that it's negative because we're going to square it anyways. So we have the square root of -8 squared, or just 8 squared if you want to put it as 8 squared, plus 3 squared. Because the x's are 8 apart and the y's are 3 apart. 64 and 9 is 73, which is my distance between the points. As far as this step right here, determining the distance between the x and the distance between the y, I don't really care if you show this step here. 8 and 3 apart. The x's are 8 apart, the y's are 3 apart. And that's the same thing as you find when you're doing the slope, except with the slope you divide. So this is something that you should be practiced with quite a lot. Anyways, Question 8, find the other endpoint. We're looking at a pattern here. So I've got my endpoint at 0, my midpoint x value at 10. So to get from 0 to 10, I had to add 10. That means my x value of my endpoint is going to add another 10 to the midpoint. So it'll be at 20. Now for my y value, the y value here for my endpoint is negative 3. And for my midpoint, it's negative 1. So to get from my endpoint to my midpoint, I had to add 2. So I'm going to add another 2 to get the other endpoint. Negative 1 plus 2 is 1. So it's 20 and comma 1. Again, when you're looking at this, find the other endpoint question, it's establishing a pattern. It's asking what did you have to do to get from the endpoint to the midpoint? What did you have to add to the x's? What did you have to add to the y's? All right, next item. Now, let me zoom out a bit there. There we go. Now you can see the whole thing at once. Find the midpoint. We add the 2 points together, and then we divide in half. So 3 comma negative 5 plus 3 comma 1. Add it. 6. Negative 4. 3 plus 3 is 6, in other words. Negative 5 plus 1 is negative 4. And then divide by 2. Half of 6 is 3. Half of negative 4 is 2. Negative 2. So the midpoint, when we find the midpoint, we add and divide by 2, because we're finding the average point. Average meaning add and divide in half. Add the two things, divide in half. And when finding the other endpoint, we're establishing the pattern to make it so that the midpoint is halfway in between. So 0 plus 20 divided by 2 is 10. Negative 3 plus 1 divided by 2 is negative 1. There's forwards and backwards questions there. What is the length of a side of a square with an area of 144? So an area of a square is length times width. However, on a square, the length and the width are the same. So I could write the area as length times length, or width times width, or side times side. So 144 is equal to length times width, and if length and width have to be the same number here, they both have to be 12. 12 feet, because it's a square. Anyway, I intend to make the front page worth 50. 5 points for each, as per usual. Make it half points on the front, half points on the back. Moving along. Page 2. Converse, inverse, contrapositive. So write the contrapositive, converse, and inverse of the true conditional statement, then circle true or false. So if it's a mammal and it's warm-blooded, all right, so all mammals are warm-blooded. The contrapositive here, converse and inverse. Let's do the converse first. Converse means change the order, change order, CO. So if it is warm-blooded, then it's a mammal. Inverse means negate. So if it's not a mammal, then it's not warm-blooded. And contrapositive is negation, as well as the inverse, as well as the converse put together. So if it's not warm-blooded, then it's not a mammal. All right, so if the original statement was true, then the contrapositive has to be true as well, because those have the same truth value, the original statements and the contrapositive. However, the converse and inverse here, we could say that these are false because some things are warm-blooded and not mammals. For example, birds. Now, in terms of true and false here, sometimes I don't grade the true-false portion of this. Some years I don't grade the true-false portion of this. I do always grade the converse, inverse, contrapositive, however. And I do always assign 5 points of value to each of these. So there's 5, 10, 15 points on the back here. And it'll be out of 50 on the back. So by the time I'm finished here, we'll have 50 total. Let's keep that in mind. All right, next question. Question 12. So the original statement is the given. So it says here given for my reason. Well, given AB, I'm just going to rewrite this down, equals 4x plus 6. BC equals 2x plus 5. And AC is equal to 23. That's the original statement. Through segment addition, we can imply that AB plus BC is equal to AC. This is what the segment addition postulate says. In other words, the segment addition postulate says that you can take AB and BC and you can get AC when they add together, because the two smaller segments make the longer segment. AC is the entire segment, AB and BC are the portions. The substitution property says we can put the values of x's into AB and BC. So AB gets replaced by 4x plus 6, B gets replaced by 2x plus 5, and AC gets replaced by 23. So I have here AB, which is 4x plus 6, plus BC, which is 2x plus 5, equals AC, which is 23. Now, to move from step 3 to step 4, the proper thing to do is to make these two into a 6x and these two, 6 and 5, into 11. What did I do there? What do I call that? That's what I'm asking you for here on the right here. Give me a reason why give me what that's called. And what it's called is combining like terms. Now my next step, we're going to do a subtraction here. We're going to subtract what? 11 from 23. So that's going to yield 6x is equal to 12. That's a subtraction postulate, or a subtraction postulate. No, subtraction property of equality. And then our final step is to take 6 into 12 to get x equals 2. And that, to get to x equals 2, we divide it. So I know you're worried about this proof. We talked about it in class, these proofs. It's going to follow a similar format, segment addition or angle addition postulates, and a similar pattern here, where you're substituting numbers in for variables or for segments or angles, where you're combining like terms or where you're distributing something to that effect. In this case, we combine like terms. We didn't do any distribution. But then where you're subtracting and dividing, or maybe you'll have to add and divide. If this was a minus 11, we would have to add 11 to the 23 if it was minus 11. It follows a similar format. Just fill in the blank. Each of these blanks is worth points here, and like I said, I'm going to make the back worth 50 points here, so each of these blanks is worth multiple points. So if this one was worth 15, we're going to make this one worth about the same amount, 15 points, maybe a little less, so that I can make it out of 30, and then this will be worth 20 or something like that, so it makes a total 50. Anyhow, just keep that in mind. It would make sense for me to make this 2, 4, 6, 8, 10, 12, 14, or 3, 6, 9, 12, 15, 18, 21. It makes sense for me to do it either way. Make them 2 or 3 per blank. All right, moving on to the last thing on this page. Last thing on the test as well. Write examples of the following properties. The addition property of equality. So what I'm looking for here is something to the effect that if A is B, then A plus C is equal to B plus C. So it doesn't have to be written exactly in that particular order. What I mean by that is I hope it's obvious to you that I'm not going to test you on this exact wording right here. So maybe instead of testing you on it like that, the question on the test is going to apply the concept. And what do I mean by the concept? Well, here would be the concept. If x minus 3 is equal to 6, then x is equal to 9. And how did I get the 9 there? I had to add 3 to both sides, because 3 plus 6 is 9. So that would be the addition postulate of equality, because I'm adding the 6 to the 9. All right, the division property. So again, the division property says if A is equal to B, then A divided by B, or A divided by C is equal to B divided by C. So that's what it says. If A is B, comma, then A divided by C equals B divided by C. Now, again, I'm not going to have exactly that on the test. I'm going to have some sort of property. So it's going to be something to the effect of if 4x equals 20, comma, then x is equal to 5. And how did I get the 5? I had to divide both sides by 4 to get the 5. All right, reflexive property of equality. This one says simply that A is always equal to A. So how do I test this one? Well, there's only really one way to test this one. I put something equal to itself. So, oh, sorry about the lights. So let's say we talk about a segment. I could say, for example, segment length AB is equal to the segment length AB. Or I could do this with an angle. Or I could do this with a triangle or a parabola or whatever. Something that always equals itself, reflexive property of equality. Next one here, substitution property of equality. This one says if A is equal to B, then A can be substituted for B. If A equals B, comma, then A can substitute for B or replace B in an expression. So how do I test this one? All right then, well, for the substitution property of equality, I would say if x plus y is equal to 9 and x is equal to 4, then I would replace the x with a 4 here. 4 plus y equals 9. Where I replaced the 4 with a y, or the x with a 4. Sorry, not the 4 with a y, the x with a 4. So I replace the value of x with a 4. 4 replaces x. That's called the substitution property. And I could also do subtraction here to get y equals 5 in terms of my finished answer. So the finished answer here would be y equals 5 for my finished answer. All right, next question. Subtraction property equality. If A equals B, then A minus C is equal to B minus C. So again, I'm not going to test you on exactly that. It's going to say something to the effect of if x plus 4 equals 9, then x equals 5, because I took 4 away from each side. The final property here of equality is the symmetric property. So this says if A equals B, then B equals A. All right, so how can I test this one? Well, I can test it with a segment. I can test it with an angle. So maybe I'll say if angle A is equal to angle B, then angle B is equal to angle A in value. So, what did we learn here? Hopefully, what we learned here, and I forgot to put a few of the properties on here. This practice test. There's a multiplication property as well. There's the transitive property that I probably should have included here, but I did not practice one. These are the 6 that are going to be on the test. But hopefully what we learned here was that when you're working the properties of equality, it's the operation that you had to do to solve the equation that matters. So to review here, addition property of equality, we had to add 3 to both sides to solve this equation. That's called the addition property of equality because we're adding 3. The original operation was a minus. X minus 3 equals 6. We added 3 to get the equation done to solve it. Same thing with the division property. The original question here had 4 times x equals 20. We had to divide by 4 to get x equals 5. So it was division because of the operation that we did to both sides of the equation. The subtraction property, we had to subtract from both sides to solve for the equation here. Because x plus 4 equals 9, we subtracted 4 from both sides to get x equals 5. And similarly with the multiplication property of equality, we'd have to multiply both sides by a number to solve it. I don't have it here on the review, but we would have to multiply both sides by a certain value to solve with a multiplication property of equality. And symmetry is again like when you have your left side and your right side of your face, where one flips over to the other. So they're not a copy and paste. It's not copied and pasted. It's symmetrical. It's flipped. It has a line of symmetry is what it's called, or a line of folding. So this is why this is A equals B, then it folds over to become B equals A. All right, so it's not A equals B, then A equals B. No, it's A equals B, then B equals A. It's flipped over. When it's A equals B and A equals B, then that's the reflexive property. That's a copy-paste. You can copy and paste something as many times as you want. Control-C, Control-V. Same thing over and over and over. Anyways, come in if you want some help. I'll be here Thursday morning before school, Friday morning before school, and Thursday afternoon if you want to come in for help on the test. In terms of point values, it makes sense again for me to do 2 or 3 points per blank here. There will be 6 of these on the test. So it makes sense for me to do 2, 4, 6, 8, 10, 12, or 3, 6, 9, 12, 15, 18 points. Something to that effect. So that I can assign enough point value here to make the backside worth 50 and the front side also worth 50 points. 50 and 50 in terms of point values. Anyways, good luck.